Hey guys, today we're going to be going over part 2 of the Stocks Finance SwiftUI app. Today we're going to be finishing off the front end, the user interface. We're going to be building out this line graph and our search functionality on top. All right, let's get started. Before we get started coding, we're going to need some math in order to figure out how we're going to plot these data points on our graph. So I'm going to write some stock prices right here. 92. All right, so here is going to be our sample stock, and these 3 points are going to be the opening prices of the stock in 3 different days. So we need to assume that between every single one of these prices, the time span is equal. So in our case, from here to here, we have 1 day, and here to here is also 1 day. All right. I'm going to draw the graph on the other side. Okay. So this is our x-axis and our y-axis. 0, 0. So what we want to get is some sort of like a few points where we can use to connect and populate our chart like this. All right, so in order to do that, we're going to need to convert each one of these elements into 2 points. We have to give it an x and a y. So how would we do this? Using normalization, something very used prevalently in statistics and machine learning, is normalizing values between 0 and 1. I'm pretty sure that's it's linear algebra, where they use normalization for vectors. But in our case, we're just going to normalize these 3 set of values between the range of 0 and 1. All right, so how are we going to do this? We're going to need to find the minimum and maximum and assign the minimum to 0 and the maximum to 1. All right, so here, this is the equation for normalization. This is going to be our normalized value is equal to our value minus the minimum divided by the max minus the min. All right, so I'm just going to change these numbers so it's a little easier to do these calculations. All right, so our minimum is going to be 30, max is going to be 50, min is equal to 30, max is equal to 30. All right, so let's start with our first number in our array, 30. So we follow this equation. Xi, our value, is 30, minus the minimum, which is 30. Sorry, this maximum is supposed to be 50. Divided by our maximum minus our minimum. This gives us 0. So we can assign 30 as 0. Let's use a different color. Okay, so 0. These are going to be our normalized values. And I'm just going to erase this so it's easier for us to visualize. All right, doesn't get as messy. I'll use a different color actually. So 40 is going to be our next number, minus the minimum, which is 30, divided by 50 minus 30. That gives us 10 and 20, which simplifies to 0.5, which makes sense because 40 is directly in between 30 and 50. So we're going to write 0.5 right here. All right, one more. All right, so our value is 50 minus the minimum 30, and we divide this by 50 minus 30. So we can see this is just 1 over 1, which is 1. And that means 50 will be normalized to 1. And this gives us the value of y, assuming that y is only from 0 to 1. So later, I'm going to show you how we're going to fix that. And this is the same thing on the x-axis. We also want x to go up to 1. So starting at 0 and going to 1. Let's start with y. So this is how we plot, or actually, sorry, let's go over y first, getting the x-axis coordinates. All right, so what we need to do is to split up, here, let's see. We have to split up the x-axis into even portions in order for us to place these numbers equally on every single, place them equal distance to each other. So for the first one, we're going to start at 0, and the last one, we're going to end at 1. And the numbers, or sorry, the indices in between are going to land in the middle of 0 to 1. So similar to what we did for the y-axis. All right, so our equation is going to be our index number, or let me use a different color. It's too dark. Let's do. All right, so we're gonna have index, or how should I, okay. Index divided by length minus 1. All right, this is going to be our equation to find the x value of our value. So let's start with our first number, 30. So 30 is at index 0, right? Because arrays, you start counting them from 0, 1, then 2. So let's write 0 on top, divided by our length. Our length is going to be 3, right? Because our array has 3 elements. So we do 3 minus 1. And we know anything divided by, with the 0 as the numerator is always going to be a 0. So we're going to have a 0 there. All right, so that means 30 is going to be at 0, 0, right? Okay, let's plot that there, 0, 0. Next, let's do, I'm gonna do 50 next, because I want to show you why we did length minus 1. So index of 50 is going to be 2, right? And we said our length is 3 minus 1, which equals 2 over 2, which is 1. So 1 is going to be the value of x for 50. And that makes sense because we said the x-axis is going to go from 0 to 1, and the largest value has to be at the furthest point, which is at 1, right? So yeah, this is why we're going to be subtracting 1 on the length. And let me just plot that. So we said 1, 1 is for 50. So 1, 1 right here. And our final, let's see, for 40, we have index at 1, right? So 1 divided by length is 3 minus 1, which is equal to 1/2. So then we have 0.5, 0.5. When we plot that, that's about center, yeah. Okay, and then let's connect the points. And that gives us our line chart. So this only works when your graph is the size of 1, but we have a really easy fix. We can make this graph any size we want, as long as we multiply the x and y coordinate by whatever number the graph, how big the graph is. So say we want the graph to be 500, right? 500 on this side as well. All we do is get these numbers and multiply them by 500. So 0 times 500 is 0. So it's going to be in the same place. 1 times 500 is going to be at 500. So it's the same thing. 0.5 times 500 is 250. So we get the same exact graph as long as we multiply by the height and width of the graph. So after that explanation with how we're going to populate our graph, I just made a new file called stock mock data, and in here we have a static variable that just always returns this array of prices. This is what we're going to use for creating our line chart, but later we're going to populate it with live data, like actual data. So, okay, let's get started. In views, let's add a new file, a SwiftUI view. Let's call it line chart. All right. First things first, we are not creating a shape in this, or sorry, a view in this case. We're going to return a shape, and we're going to wait for it to give us some errors. All right, so whenever you make a shape, you're going to need to have this function. The reason why we're using a shape instead of using a view is because our line chart is going to be drawn. I want it to be drawn instead of like, it's going to be really hard for us to actually draw the, whoops, I'll just let that go for now. It's really hard for us to draw a chart using SwiftUI, like text variables, like rectangles. It's going to be really hard. It's so much easier if we just draw the path and just return it that way, especially since it's going to be a line chart. All right, so let's see. I want you to create a new extension. We're gonna use this for normalization. So we're gonna say extension array. Yeah, extension array. Where element is equal to CG float. So what this means is we're going to make an extension for arrays that have elements equal to CG floats. So if I have an array of, let's say, var people or var places, sorry, let's do states actually, that's easier. California, Washington, New York. This would, when we have this variable normalized values, this will not work. So if we say states.normalized, see, it's not going to allow us. Property is defined on array and may not be available in this context. This means that that this extension only works for arrays where elements are equal to CG floats. So instead, if we use stock mock data.apple, then we say .normalized value, it should work because now we do have an array with CG float. All right, so let's write this out. So normalized values, we're basically just gonna kind of return an array of CG float, and this is how we're going to do it. This is a way to write functional variables. So it's just, you can write extra code inside this block by opening curly braces. So here I'm going to introduce you to two of Swift's built-in functions if you don't already know. So self.min and max.min, or self.max, self.min and self.max. This is going to return us the minimum value and the maximum value of this array. And that's basically what the self is. The self is talking about the array that we run this, we get this variable from. So if we can get a minimum and maximum, I want to return self.map. That means we're going through every single, it's kind of like a for loop in, we're going to iterate through every single one of the elements. And inside this map, I want to transform it. So this $0 means the value, kind of like when you have for x in array, x is going to be what $0 is in this case. So minus min, because we said in the explanation, our equation is value minus min divided by max minus min. Let me open some parentheses here so it doesn't get too messy. Whoops, my bad. Divided by max minus min. All right, so this should just return us all of the normalized values. Then we need to account for the case in which we don't have a minimum or maximum, and we just return an empty array. So in what cases will we not have no min or max? If we had an array of one number, we wouldn't have a maximum or a minimum because there's only one. So that's when we would return nothing. All right, so now that we've written this out, let's get back to our line chart. And let's get writing our actual line chart code. All right, first let's get, let's put a variable, let's put a variable here. So we're just gonna say data is going to be of type CG_float, an array of CG_float, sorry. So this just means that whenever we call the line chart, we're gonna need to pass this data in. For now, we're going to say stock mock data.apple.normalized values. So this returns all the normalized values. Nice. Next, we're gonna work inside of this function, this path function. So we're gonna say func convert to point. This means that we're going to do exactly what we went over in the math session, where we had to convert these values into our values on the graph over here, these ones. All right, so we need to pass in the index, and then we need to return a CG point. CG points here in documentation says a structure that contains a point in a two-dimensional coordinate system. So this is exactly what we want. We want an X and a Y for each of our CG points, then we can plot them on this chart. All right, so we're gonna return this, open up our function. Let point is equal to data.index. So this is going to give us the exact value of whichever index that we're gonna work with. The reason why it's gonna be index is so that we can iterate through. Later, it's gonna be easier for us to iterate through, especially since finding the X point is going to require our index. So we should just pass it in first. So we're gonna find out what X is going to be. X is equal to sorry, let's not do that yet. Let's do CG_float. We need to cast our index to a CG_float in order to, since CG point only takes 2 CG_floats, we need to cast our index to a CG_float. So when we divide it by another CG_float, CG_float data.count. Nice. So let's see. We're not done yet. We need to do the Y, or sorry, I almost forgot. We said in the explanation that we need to multiply. This is only going to return us a value from 0 to 1, right? So we're going to have to multiply this entire, we're going to have to multiply our range from 0 to 1 by the width of our graph. So in our example, it was 500. But here, it could be different. So we're just going to say rect. We get it from this path, rect dot width. Rect dot width. And then we need to multiply that. Next, we're going to do the Y. Let Y is equal to 1 minus point. We already, normalized it, so we're good. Times rect dot height. Same thing as before. And now we can just return a CG point that we instantiate right now. X and then Y. Nice. Okay. So now we just have to make our path. So we're gonna say return path P in. So to think about the path and drawing a shape, just think about your hand holding a pencil that you don't lift up. So in this case, when you're holding your pencil, you're gonna move from point A to point B, and that's gonna draw a line, right? Point B to point C draws another line. So that's exactly what we wanted to draw the lines with. So this is point A, B, and then C, so it goes straight. So here we're going to say if data.count is less than 2. Basically, that just means if we don't have if we have a data or our array is only length of 1, just like what we did in extensions, we're not going to have a minimum or maximum if we only have 1 element. So here we're going to say if data.count is less than 2, we're just going to return nothing. Else we're going to say that means we have more than 2 points, which means we can actually draw our graph. We can say start is at data.first, so the first point. Then we say p.move, move to CG point. X is going to be 0. Y is going to be 1 minus start. And start is going to be an optional, so we need to cast this to be 0 when it's optional. Optionals just mean nullable variables. So in this case, there's a possibility. Well, actually, we don't need it. We don't need it. Actually, we do. It's an optional, right? Xcode's telling us it's an optional. So that means there's a possibility that it could be nil. So for example, if data is equal to this, there's not gonna be a first element that we can pull from. So yeah, that's all we have to write some data or error handling. Otherwise, our app would crash if that happens. Rect.height. All right, so now we have to do for index. Whoops, that's not how you write for loops in Swift. For index in data.indices, we're gonna map through all of them. P.addLine, so imagine your hand holding the pencil. To convert to point, we're getting the points, index. All right. Did I miss anything? 1 minus start. Sorry, I'm missing some parentheses there. Let's see. All right, so great. At least it shows up. That's good. So what we need to do here is change it to stroke. Let's do color.light green. All right, great. Now it's showing our graph. And then frame, I want this to be a little smaller. Let's say width of 400, height of 500. And let's see. Whoops, deleted the whole thing. All right, so now we have our graph. That's good. I'm gonna add a little bit of padding so we can, yeah, all right. Cool, so now we have our line chart finished and we're gonna put it inside our code now. Watch list view. And we're going to be implementing our, we should be in our stocks card view. And we're gonna implement the graph right now that we just built. So in text, let's delete that and let's replace it with line chart. Open it up, data, we're just gonna stick with mock data, .apple, .normalized values. And we're gonna need to do stroke. And we're gonna say color, what was it? Let me look at what the colors are. All right, so color light green. And line width, we're gonna do 1.5. Nice, so now we have, this first parameter lets you change the color of whatever you want. Later, we're gonna make it dynamic, so if the stock price is going up, we're gonna have light green. If it's going down, it's gonna be red. And this line width, you can change this to whatever you want. I like 1.5, but you can do whatever you want. All right, let's run it just to see what it looks like. Nice, nice. All right, so our last thing on the list today is building out this search pop-up UI. All right, so let's see. Let's make another view. I'm gonna call this view a search stock view, and let's just import it inside our where did I even put it? Right here in our content view. We're just going to put search stock view. Whoops. Search stock view, like that. And we run it just to make sure everything works. we open search. Yep, we have hello world. Nice. Okay, so here we're going to start with the VStack. And we're going to have a text field. Inside this text field, we're going to say stock ticker symbol. This is like the placeholder for the text view. And then in the text, we need a state variable to hold this. Private var, let's say search symbol of type string. And we're going to set it to an empty string. $sign search symbol because we have to set it as a binding. And let me run it just so we can, whoops, I forgot a comma right here. All right, so that looks pretty bad actually. So, but you can like type in it, so that's good. We have our functionality done. Let's add a little bit of padding on this text field. And our background, I want what we had before, like that nice rounded rectangle. So we're gonna say corner radius of 10 and style dot continuous. Okay, and now we're gonna have a stroke color dot dark blue line width of 1. All right. So then we just put a padding outside all of this, and that looks really good. We have our text field done. All right. And I don't want any auto caps, so we're gonna say text input auto capitalization. We're gonna set this to .never. All right. So I do want a divider here in between this, and let's just push this all up with a spacer. All right, so now it's at the very top. Whoops. And let's say stock cell. Actually, we have not built that out yet, so let's make another file called stock cell. Save that. So our stock cell is going to have let stock is of type stocks of type string. Sorry, string. It's going to be nil if it's gonna be an empty string if you don't pass anything to it. So we're gonna have an h stack inside of here. Text is just gonna be actually we need a description too. String. So text stock dot font dot title 3. I'm just gonna go a little faster on this because this is pretty self-explanatory. It's just some styling things that I prefer, and you can change this to whatever you like. Dark blue. Let's run that. What is happening? Oh yeah, sorry, I forgot to pass in the stock. It's gonna be, say, Apple, and description. Oops. Oh my god. I really can't spell. Apple. Descript. Apple computers. And sorry, I forgot. You can't do this. Does that work? Description. Okay, nice, it's working. So we have Apple front and center. Then we have spacer. I want this to be a min length of 0. This means that the spacer is going to be 0 if the description and text stock symbol are too long. Then we're gonna have text description dot foreground color dot gray. All right, I like that. Now we're gonna have a little bit of a padding, and I want the background to be completely white. Okay, that's good, that's good. Let's go back to our search stock view, and let's add a few of these. So stock cell. Description, Apple. Divider. Oops. Shouldn't have added that many. Alright, I'm just gonna copy and paste a few of these. Okay, let's format them a little bit. Yeah, looks good, looks good. Let's run it all. Whoops, what happened? Okay. Nice, we have our graphs working, and let's see our search view. Nice, nice. We have our searchable, or it's not searchable yet, but usable text field at the top, and we have all of our cells at the bottom. All right, so that's gonna be it for today's video. Part 3 and part 4 are gonna be about connecting the backend and actually making some live data. So stay tuned for that. And just so you know, in the description below, I'm gonna have every single one of the GitHub repos listed, so you can just go in and select a different branch for whichever part you're on, and you can check the code if you have some issues running, or you can just put a comment down below and I'll see if I can help you out. All right, thanks for watching, guys.